Yeah. So, folks, yeah. So, good afternoon. Hopefully, you had some good lunch, and I'll try to keep you awake. That'll be a challenge for me as well. So the real ask is I'll go through the problem statement, but the ask and let's take the objective. Why are you all here, right? I mean, why are we all here? We want, I mean, whether you take it, one continent or one country or an overall, right, as the world, we need a lot of real good engineers. Okay. And you all have chosen to do engineering for one fact, assuming it's a good job and you'll have a lot of career prospects and maybe have good pay. But then you might have accounted it or not accounted it is engineer is a student all their life. Okay. I'm 20 years out of 26, 27 years out of college. I have to learn every day. If I tell them that, I can code in Python or maybe C or something, they'll say, yeah, that's great. But, today we are using Rust. And they'll ask me, do I know GenAI? And I'll say, do you know how to train a language model, LLM, right? Can you do a domain specific language model? I cannot say, yeah, but I have so much experience. Not going to help. Contrast that to a doctor who is doing a cataract surgery and they says, I've done like 5 million cataract surgeries. We'll be happy to refer our friend so that their mom or dad can do a cataract surgery with the same doctor. Okay. So engineers have to learn every day. Technology changes every day, and we push the limits. Engineering is not a degree. Okay, it's a mindset. Okay, it's not what you get from college. So it's not necessary the degree. You could be doing finance, HR, or anything, but you still have to have that mindset, engineering mindset. So we all decided to be on that path. So let's make sure, and we push the limit, right? I mean, I met one senior IEEE fellow once. He said, both my sisters are doctors, but he proudly told them that, the reason a doctor is able to solve something or heal a patient or cure a patient or take care of the surgery because there's an engineer. Okay, there's a CT scan, there's an MRI, even a basic stethoscope comes because there's an engineer. So we need to have the mindset, and all of you are the future of the world for being good engineers for the world, right? So make sure that you stay to that promise. Unfortunately, we don't have a Hippocrates oath like how the doctors have. We all have to also understand. You can go to IEEE site and look at their vision and mission, and it says technology for humanity. Okay, so our job is to make sure as the world gets better and better, how can we live with the minimum resources and how we create products and technology that everyone can get access to, right? It is not like only the rich or somewhere close to the rich or middle class can only access to technology. We need everyone in the system, every person on this planet to have access to technology and at a reasonable cost, right? We cannot build AI models or machine learning or next generation of artificial intelligence, which takes gigawatts of power. So everywhere as an engineer, you say, can I do it better? Can I do cheaper? Can I do it lower resource constraint, right? Can I offer it at a cost that everyone can afford? So that's the background. We'll switch to the problem statement and we'll go through that and then we will have a dialogue, right? Don't think it's a monologue because that way we will not learn. Okay. So let me switch to the presentation. Okay, let me do one thing this way. It's easier that. Okay, so hopefully you can see my screen. I'll blow it up into presentation mode. Yeah. We'll go through the problem statement and stuff. Then you can ask specific questions. We'll have a dialogue. You can, as Rabanta mentioned, we can have a dialogue. You can unmute and you can ask, or you like to start posting your questions into the chat. That's also fine. Okay. So as I gave that prologue, the pre-discussion, right? All our learning has to enable something in the industrial world, right? And whatever we're doing, it could be industrial, it could be something related to sustainability, to the ecosystem, ecological, right? Whatever. So we have to keep ourselves ready for the industry and for the world. So one of the problems that we're taking here is what happens today every day, right? And you could be mechatronics, you could be triple ECE, or you could be studying computer science. It doesn't matter what's concept you know, really the value is when we apply the concept. So application is key, right? Not knowing a bunch of names and algorithms and throwing words like Gen AI or machine learning or deep learning and TensorFlow, whatever. Can I apply it or not? If you are not able to apply it, then we are not ready for the world. Okay. You can go back. You're all Gen Alpha or probably Gen. I mean, maybe you're probably Alpha beyond Gen Alpha Z, right? So you can access the internet. We have a lot of people studying and doing this data science and AI, machine learning, and a lot of even advanced mechanical subsystems, right, and process control. The thing is, are they able to apply their knowledge in the industry, right? So your focus should be, can I apply my knowledge? Okay, because there's a lot of need, but then we are not able to fulfill the need because there's a gap in how we learn from school to how we apply in business. Okay. Okay, so I'll switch to the topic. We are trying to take an example which is pretty widely used in a system, right? One is the labeling piece, right? So you could be looking at a label on a medicine sheet which has the batch, the date and time or something, and the expiry and so on, right? To even something like a hand wash or a soap uh, or any other product, right? Labeling is important. And you might think, okay, that's fine, but what about this traceability and quality? So fundamentally, whether it is a medicine or something that goes into a product, right? You could be manufacturing something that's going to an automotive system, a car or something, right? Or some critical system, could be a vehicle or it could be MRI machine or something. We need traceability. And you might have heard of in the last few years, or generally it's there, but you might not have heard of it. It's called recall. So what happens is when companies manufacture products, they sell it, and then they realize that someone comes back and says, oh, this is not working. Then they realize, oh, we messed up the process in the manufacturing. That batch we used some machine broke and it sent the wrong product out, right? So it has a fault. It's thing like you have this ABS in your car, right? When you brake, the ABS tries to brake at a certain pace, so you then suddenly brake and your vehicle will turn, so it makes sure that it is taking care of that. But imagine you're driving at 100 kilometers per hour and then you try to hit your brake and the ABS somehow doesn't work. So that's a dangerous situation, right? So, and let's say it fails. Someone complains back to the company, right? So they need to trace. They need to say, oh, this ABS system was manufactured in this year and this month on this batch in this shift. I need to validate all that batches, all that product that was manufactured during that shift or that day, or probably the shifts before and after, because maybe this fault went into all those ABS systems. So I need to trace them all the way and figure out, maybe I should recall them because that can hurt many more people. So traceability is the very key of any of these manufacturing systems. It's not like making balloons or something, right? We're talking about complex systems that probably are protecting people or helping protect people, right? Like in the automotive phase, or even stents, even pacemakers, right? So they are all things that are getting manufactured, but we need traceability for those. So those are the two pieces. One is labeling, the other is tracing back after many years. So as per the law, most of the automotive systems have to have 15 years of data. So any company that manufactures a ABS braking system has to probably maintain every batch and lot and detail of every unit produced in their database for 15 years. Because anywhere in that 15 years, something can go wrong and the government will ask, show me the traces, right? Did you do the right due diligence to recall your products? Okay, so this is one key thing that is every manufacturing industry needs this. So what comes into labeling and traceability? So I just captured few details: a device ID, batch ID, the manufacturing date, ROHS, so on, right? So, and then the system will that we are going to build, or your charter to build, is going to have multiple things, right? Because you're doing labeling, you're also doing traceability. So there's a database, there's logging, and then you have to be able to track it back. So that's the initial objective. By doing the objective, what are you trying to get to, right? I think we'll have maybe that section a little further also. The idea is you need to apply your concept that you have learned. Okay, if you're not able to apply what you learned and demonstrate that learning, then we have not learned anything. Okay. So I think I've already harped enough on the background and the problem description. So you can go a little further. You'll get it, the level details. So you need to, if it's a barcode or some character thing, then you need to apply OCR or some kind of image recognition. That's one place. You need to be able to log those products, right? I mean, how do you do this? We'll talk. You can have simulators, you can have software that simulates these scenarios. We'll talk about it. Okay. So what are the deliverables? At a high level, I'm not expecting you to do a great, very detailed system architecture, but it will show you how does this flow happen, right? So a flow are two parts. At a very basic level, it could be a data flow and could be a process flow, right? So when, how does data come? Actually, when in the real world, a process happens, right? What is a process? You manufacture a product, then you label it, and then you qualify, certify it, and say it's okay to be sold, and then someone you sell it off, right? So during all this process, data is created, right? So initial it says, okay, is this product made to this spec? So that's some piece of data, right? And then once the product is tested, there are some metrics, okay, that says, okay, this pressure can be applied on this. This product can take this much of heat, or this can take so much of power. So all those have to be tested. So that's another piece of data, right? Then when you sell it or when you move it on the market, then you sell it to a distributor or someone, and you're having you have regions where it's sold. So you can say, okay, you might have a warranty to it, like, because some customers like you brought laptops or fridge or refrigerators or something, you have warranty, right? So that a year later the customer comes back, you should be able to say, yeah, I agree, you bought it on this date. From there, I have a 1 year of warranty. So every process results in a data being created or being updated. So that's fundamental, right? Without a process, there's no data being created nor updated. And then you have all this, inspection that I'm talking about through simulation. So the ask is, you can, if you have some physical hardware or something, you can try it, or you can use some simulation software, which we'll talk about in a little bit, and try to produce or simulate the system. Okay. And then you have these AAPs where, okay, you might have some label and you want to say, how do I get OCR out of it, right? You can even take a label from any product that you have at home, or somewhere in general. If you Google, you might, some products labels will be there. So you should showcase that, can I use OCR, and how my module will pick the OCR data from that and then save it, right? And track it. And then the ML model. So this is the other piece. If you are not purely computer science or triple or someone, and you have some mechanical and other understanding, yes, you can go into, I guess mostly mechatronics, mechanical students are, or industrial engineers, production engineers, instrumentation engineers, they are all taught about control systems, right? So if you have heard or have studied, you can leverage this piece, right, and try to put something around that. Okay. A control system has feedback loops. You can go and try to even enable feedback loops and do some things, right? And then the whole traceability piece. You can showcase, okay, I have like 10 products I produced in 10 batches in 10 shifts, and these are the batch IDs. Now you should have an interface, or at least be able to query, if not nothing else, a complex interface, query for a specific batch, right? And imagine and remember that in a factory, no batch comes through just one machine. So typically, even if you take, for example, your iPhone or a phone, it won't just come through one single machine. It comes through n number of machines. Finally, the phone gets ready. So your traceability is also talking about what all machines it did go through at what time, right? So that you should be able to track which machine could have gone wrong. Sometimes based on testing, quality testing, or testing of the device, you will realize, oh, which component or which machine resulted in that fault. Okay. So that's the traceability piece. And then you can demonstrate your project. Mostly the demonstration, I would say, whether you talk about it or not, at least you should have key nuances. It's like selling all your hard work, right? So how do you demonstrate that, okay, I know this concept about some mechanical thing or some electronics thing or some machine learning. How did I demonstrate that learning through a particular deliverable? That's the key in the point 6. We'll go from a high level rubric or like the scoring part, but that's not fixed. Your other mentor who will help you, guide you, and maybe your college, they can decide to change the scoring. But I just want to give just a guidance on that, right? So, and then I want to cover some bunch of tools, right? See, end of the day, we all can't create or buy expensive hardware and dedicated hardware and all that. So I would prefer, I mean, if instead of spending money, if you have access, that's fine. If you have Arduino or board or Raspberry Pi or anything like that, or something in your college, that's fine. Otherwise, try to use some simulation software, right? So a bunch of software has been mentioned here. And I think I had a link, or you can even Google online. Some of them are free for students. Even for companies, they will be sold. But if you register as a student, you will get free license, right? Yeah, free usage. So you can definitely use some of these. Tinkercad is one basic one. I had some other pieces in my other presentation, I think. Yeah, you can look for online for some mechanical simulation software. I forgot. It's like a robotics kind of software, which can also simulate complex environments. So those are all free for students, particularly. Okay, so that's the next part. And roughly this is the breakup. And if you see, the criteria is on your learning. So 1, 2, 3 are more like the percentage. I would focus on your learning. What did I learn in my college? What do I handle on what subject, right? And am I able to articulate that subject or apply that subject in this use case, right? If maybe the line items that I've given may not be exactly fitting to that, if you can tweak it and make it still apply, that's great, right? Nothing wrong about it. But essentially, the core idea is, can you apply what you learned? And do you see the application of what you learned? That's more important, right? If you can see it, see, the catch is the real world is not like college. It's not a syllabus. When you get into a job, every day some challenge comes up and you start asking, okay, what should I do about this challenge? What options can I? The basic thing about an engineer is, given any challenge, they should say, oh, let me try A, B, C, D. Oh, A doesn't work. Okay, let me try B. Oh, B partially works. Okay, let me try C. Oh, C and B together can make a great job. But let me check out D, because maybe D is like a resource cheaper or faster or better. So that's what we have to do. Engineers are supposed to come with options, try them out, learn from them, and then apply it further. So there are two key concepts, I would say. It's called design of experiments. You should read about it. And theory of constraints. So everything in the real world has constraints. So when you design systems, you will have constraints. So how do I bring the best of what I can do through experimentation, through DOE, and apply the constraints so that the system actually delivers? Okay. And then there's a bunch of other sections where some scoring is suggested, but this will really be the decision of your external mentor and your college. I think that I don't want to get into too much into that. Okay, broadly, there's just a kind of a criteria suggestion. Yeah. And yeah, there are few data sets that I think are there on the internet, which you can possibly pick and start using. And you can apply additional things like PCBs particularly, and some products like will have labels and stuff. So that's good. So you can try these things as an initial data set instead of you creating one. I would say don't get hung on the data set piece. Many times we just say, okay, it's like we overwhelm ourselves trying to get stuck on, okay, do I have a data? Shall I try this or that? It's, see, like, success is about making progress. Okay. So if you are stuck and you're not making progress in a day, maximum two, then it's not worth it, right? So as you make progress, you will learn. So always making progress is important. You try, if nothing works, no data set is available, you just go home and pick a bunch of the medicines. On that there are labels, stickers will be there, or you take some sticker from the internet, like just look up from labels with barcodes, without barcodes, and try to start building the system. Okay. Yeah, that's all pretty much I have on the flow. I'll pause here. I'll just jump to the first page, and I would like to hear from you. Can you, yeah, you can unmute or you can start sharing, yeah, typing your chat on chat. Um, yeah, I think all of you should be in. I'm not sure. Okay, let me, I said I'll, okay. Yeah. Can you,
guys, you can unmute yourself and ask queries.
Yeah, please. Yeah, if you're not going to ask today, I don't know what you will do tomorrow. So please. Was that like, I mean, even if it means basic, whatever I explained, maybe I was not good in explaining that. Yeah, even if you want to harp on a specific piece of it, you want to get some detail on that, I can dump this sheet here for you. Maybe you guys can download it. It might get just sent with the team, but yeah, I can just make sure that it's available to you now also as well. Yeah, please let me
Sir,
know. Please go ahead.
sir, will we be able to will we be able to do it on our own, or you gotta teach us the theory or something?
Yeah, okay, good point. So I don't know if there is any specific theory that I want you to recreate or something. It should be part of your subject and your ongoing learning is what I would say, right? So are you telling that you probably don't have a concept? Like for example, let's say you have not studied mechanics, right? Or you're a computer science grad and you don't know what is a actuator and you're trying to build it or try to do something. Yes, I think that will not be covered as part of this session. You will have your industry mentor to guide you. Yeah, the idea is what you and okay, maybe I should also add this, right? The idea is you are not going to do this alone. So if your college has I don't know, Ravanda, you can add here if other colleges can join, but in a group you can have someone from CSE, AI/ML, data science, or and mechatronics, electronics. So that as a team, so this is how the industry works, right? When tomorrow you get into a job, your team will not just be a bunch of computer science students or mechanics, right, or mechatronics or electronics. You will be a team of people from different subjects, right, different education backgrounds. So really, in the real world, how the way we deliver all of us is really using a team of different people. So yeah, in summary, my friend, yeah, we're not going to do any special training on that. But yeah, you will have some general guidance and you have to leverage the system to be able to do it, I guess. Yeah. Okay.
Okay, sir. Thank you.
Yeah. Uh,
Hello, sir.
Rabanda, you
Uh,
want to add something? Yeah, please.
so I was asking that you tell us about the traceability and the other thing, but you didn't tell us about the quality check.
Sorry, quality check. Can you, did I, oh,
Uh,
the line
that
in
was
that, you mean
that
the line? Mhm. Please go ahead.
that was mentioned in the problem statement, no?
Yeah, yeah, quality. Yeah, again, so it's all similarly again, right? So traceability is a result of either. So okay, before you send the product out, you will have quality issues. So obviously, that one part is it's inherent to that, right? So you can say, for example, you can create a system like in this case label, right? So if I just harp on label only, and this is foundational to any manufacturing company. You take a bottle of hand soap that you are buying, right? You see there is a small sticker. Sticker has a definitive size, and there is supposed to be a batch and stuff. And that the batch and that time and expiry should match a database, right? It may not be. We don't want to get into product quality, right? But let's say we are only harping on the label, and then using the label we can trace back to the product and then we say this product was made on this day, right? So like I said, the ABS doesn't work and someone says, oh, I bought this ABS from you like 5 years ago. Now I want my money back or something happened, right? Maybe some case, some official, judicial case, crime, criminal or whatever, right? So the thing is the company has to go back and based on the label, they'll figure out which batch and they'll figure out the whole issue. Was it a quality excursion? What parameter did they not test? All that will happen. So those are things that is implicit in the problem statement. So you can decide, okay, maybe I'm selling soaps, right? And I get a soap bottle back, right? So now the customer would have said this soap doesn't work or it's too liquidy or something, right? Now you can decide my one of my quality parameters is the concentration of the soap. You can just come up with some number. It's not like I have to specifically give you something. You say my parameter doesn't test a match, right? But that parameter has nothing to is like the underlying concept, right? So when the soap is returned by the customer, you're going and looking at the label and figuring out which batch did I run create this product and did something go wrong? Did someone tweak that machine which was mixing a lot of these chemicals and water to make the concentration is off parameter, right? So it was supposed to mix like 10% water and 90% of those chemicals, but it somehow became like 12% and suddenly or 15% or something, right? So you can say, oh yeah, but to get to that, you have to have your traceability back. Hmm? So I'll give you that. Yeah, good question. Thank you for suggesting, because others would have similar thing. You can come up with that parameter, right? Whatever might be your quality parameter. Yeah. And sorry, I didn't catch the name,
Okay,
but
okay,
thank you. You are anyone who
okay, sir.
speaks. Yeah, Shiv Kumar, is it? Yeah.
Yes, sir. Yes.
Yeah. Thank you, Shiv Kumar. And please do this. One other thing,
Okay, sir.
right, friends? I tell you, in a crowd, there's a difference between mob and crowd. You can look up it. In a crowd, one who voices is speaking for a lot of people. A lot of people have questions. They don't want to ask. This is what you'll find even when you get into your corporate career. Okay, in your teams, you'll find people like everyone wants to ask a question, but only one person has to stand up and ask the question. So train yourself to step up and ask, because you're helping a lot of other people. Okay, it's okay to be a fool a day than be fool all our lives. So better to ask the question. It's okay, right? Thank you for speaking up. Yeah. Anyone else? Is it helping, Shiv? Sorry, I don't know whether the answer was
Uh,
making sense.
yes, sir. It kind of helped because now
Yeah,
I
see,
can
I
like.
can be very prescriptive, Shiv. What I'm trying to also harp, right? See, my friends, you're all the next generation. We have a lot of hopes for you. There's a lot of serious, I mean, like even if you take the country by itself, right? We need you to
Yes, sir.
start thinking. And so I don't want to constrain you by saying, oh, this is the only quality parameter you want to take. Come up with your own quality parameter. Like, suppose, for example, I mean, if you're mechanical students, you're saying, okay, I make brakes, okay, or I make transmission or something. So what is the parameter that you think is quality specific, right? Like you might have seen, I don't know if you've gone to this IKEA store or someplace. I don't know in India how they have it, but they put a chair and they put a mechanical arm on that and say this mechanical arm has been pressing this chair for like 150,000 times, and you still see the chair is not bent. Okay, so
Yes, sir.
why do you use the chair? People sit on it and get up, sit and get up, sit and get up. So you need a way to test that chair for 150,000 or more, pressure point, right? And with so much weight. So it's your ingenuity, your creativity to say, and maybe your domain understanding, right? Whatever you're designing, like suppose you're designing a switch, a power switch, right? A switch that people power on, off, on, off. You probably want in a lifespan of maybe 50,000 times. Maybe people build a home, last for 20 years. Each day they put the button up and down, on, off, maybe 5 times. 20 years, 5 times per day, multiply. And you have to have a quality test to say, if I do this so many times, it should work. Okay,
Yes, sir.
thank you. Anyone else? Friends?
Sir,
Please.
sir, can you forward that PDF?
Yeah. I will just send it to the mentor here. They will send it to you. Yeah. I think I don't have an email ID or something. They will share it with
Yeah,
you, all of
we
you.
will share the recording along
Yeah.
with these PDFs
In
and other.
yeah. You will get it.
Okay, sir. Thank you.
Yeah, I think there's some confusion, Rabanta. I think someone got into the wrong. Yeah, this is not the image sharpening thing. I
No,
think
no, no.
okay, maybe
Yeah.
they got in the wrong
So
session. Yeah.
please check out the schedule, calendar schedule which you have mailed to all the nominated students. We have clearly mentioned the date and time for the respective problem statement. And if your
Yeah.
problem statement has been changed, please write an email to Intel_Unnati. I am writing it in the chat box. Intel_Unnati@intel.com. If you have any confusion with regards to the problem statement that you have been allocated, or which you are like which you don't want, or it has been allocated to you by mistake, then please write an email. We will get it resolved.
Yeah. Sorry, my friend. Yeah. Karan, I think you might be in the wrong session. Yeah, I'm just thinking. Yeah. Please go ahead, friend. Any questions, Tim?
Good afternoon, sir.
Please, yeah, right.
Yes, sir. So I have a question. Will we be provided with a flow chart or should we go with our own flow chart?
Yeah, this is so. Yeah, there's no flow chart. You can come up with that flow yourself, right? So, okay, there are when you ask that question, and like I was explaining, sure, right? So, when you get into corporate world, right, there will be a product team, a design team, and you could be one of the resource who is actually working on building that system. So you'll be constrained by that. But here we don't have all that. Let's say you and your friends who are decide to work on this problem, you come up with your own design, you come up with your own flow, but fundamentally, you have to show at the end of the project that I know these concepts, whether it is machine learning AI or if this is mechatronics or mechanical or this communication thing, because I'm trying to read signals of a sensor and do something, right? So you say these are the concepts I know and I've learned and I'm applied in this project, right? So that's pretty much the key ask. So no constraint on, yeah, you want to put a flow that helps, yes, you can do that yourself.
Okay, sir. Got it. Thank you.
Yeah. So we're just giving a general framework for you, and my friends really understand you. You can look around. The world needs a lot of ingenuity and creativity, and I think you've been harped, and people have been talking like this. AI is going to take out us and take out the jobs. Frankly speaking, you can Google online. There is a HBR article, Harvard Business Review article, which says AI is not going to take your jobs. People using AI will take your jobs. Okay. And the second part with AI will write code, but that's not this going to help. You need AI is like Jarvis. If you've seen Iron Man movie, right? Iron Man cannot be replaced with Jarvis. Jarvis is supporting Iron Man, right? So AI is only a tool that will empower us. We just have to make sure we can leverage that tool, right? And then deliver what we are delivering. So no constraints. Think that, and there's a lot of this human thing, right, which cannot go to AI. So yeah, so unlimited. Sorry, Disha. Yeah, that's what in summary. No prescription here. Okay.
Okay, sir. Got it. Thank you.
Oh, anyone else? Any questions, team?
So, if we want to learn more about this topic, are there any research papers available for this?
Yeah. I mean, there. This is not a one-off case. This is a very specific problem. You may not exactly call it. Some may not call it labeling system. They might call something, but traceability, yes. This is very fundamental to whatever happens in the manufacturing world. Okay. Okay. So anything
Okay,
that is
sir.
made today, yeah, that is anything that is made today has to have traceability. So, like for example, someone might be given a medicine, and that medicine might be costing like 50,000 rupees. You never know that medicine is actually the real medicine that the company shipped from some part of the world. So the pharmacy industry has been told something called uh, track and trace. Every batch of medicine that goes from a factory and gets shipped to maybe a bunch of airlines and bunch of carriers and reaches to a store, if they should be able to trace it to what all hands changed, because it would have gone into a country where someone would have taken the original medicine which is each 50,000 rupees and they put chalk piece or something in it. So this is a definite problem. So what results out of these issues without traceability is all this fraud, right? And adulterated products, or even the wrong product. So that is a very standard need, and it's been done today, right? Traceability is done for quality issues, like she was asking, but it also been done for fraud, right? Because people, even at those point that you could buy, for example, a iPhone watch, and you can go back a year and say, "Yo, it's not working." But what you would have done is you would have taken some part of that original iPhone watch, put another make which is probably looks like an iPhone watch, and you want to return it. So your shop fellow has to validate that watch is really that same iPhone watch that they manufactured. It's not some fraud, some, what is it called? Some made in some other company, right? Because if they want to return money, they should not return you 50,000 rupees. They should only return you 500 rupees, because that other device is only 500. Okay. So you'll find, yeah, in summary, yes, there is enough research and work happening, but the research and work might not tell you exactly the solution, right? It will be the concepts that I kind of gave you at a high level. Okay. Yeah. I'll summarize the key ask in a bit. Yeah. Yeah. Any other questions before? Okay.
So
Let
what
me do one thing.
actually is
I'll
traceability?
please
I'm
go ahead.
still not getting.
Sorry, can you repeat? I could not hear you. Hello, someone had an input.
So what actually is traceability? I'm still not getting it.
Oh, traceability. Oh, okay. Yeah, let me give you one more example, right? So traceability is, let's say you make brake pads, okay, or disc brakes. So even the basic cycles today have disc brakes, right? Uh, you might have seen a steel wheel on your vehicle. So let's say we make disc brakes, all of us. We are in a company, we make disc brakes. And we sell it to BSSLR, to maybe even Maruti's, to even Porsche, right? And so they put these different types of disc brakes that our company manufactures and they put on these vehicles. And let's say someone is driving a Porsche at 100 kilometers per hour and they try to brake and the disc brake doesn't work, it cracks. Instead of actually holding the and slowing down the vehicle, let's say our disc brake just cracks under the pressure and there'll be an accident. Okay. So now Porsche, the customer will probably be dead or probably have an issue. They'll go to Porsche and say, what crap did you sell me? I paid you like a crore or something to buy a Porsche. And now tell me, pay me 4 times the money. And Porsche comes back to us and says, you know, guys, I trusted you. I bought disc brakes from you. What happened? So what we are supposed to do is take that batch ID of that disc brake that was put in that car, go back to your system and figure out when that batch or that disc brake was made. It could be made in the last month, could be last year, could be 5 years back, right? So we have to look up our database for that lot, that batch. And then when we do that, we see in our database that one day, let's say November 10th of 2024, we made 100 or maybe 5,000 of these disc brakes. Okay. Then we say, oh, it's not just this one disc brake. Imagine tomorrow one more Porsche goes and breaks and dies, right? Something happens. Or, you know, I sold the same disc brakes not to Porsche alone, to Lamborghini or Mercedes. So what we have to do as a manufacturing company, we have to find out all those batch lots and immediately start sending mail to all our customers, whoever has been using our disc brakes, where these batches were sold. And then they have to say, please don't use these brakes. I am trying to do some homework. And if you used it in some cars, please make sure you recall the car and replace it on their side. On our side, we have to go back and say what went wrong. What manufacturing defect resulted in a disc brake that cracks under pressure? Okay. And then we figure out, oh, that day we had a power problem which resulted in certain issue with a manufacturing machine. And that machine was not testing the brakes at the right way. And so some faulty brakes went through the line. And so we cannot fix that because anyway, the batch is gone. The only thing we can do is recall all the batch. Okay. But imagine the problem. From November 11, 2024 to today, I would have made 100,000 such disc brakes. But I need traceability, right? And that brake being fragile or whatever, however it is probably not one machine. It went through say 10 machines. We have to figure out which machine resulted in that brake being bad. Okay, the disc brake being bad. Is that helping, Abhay? That's traceability. Is that?
Yes, sir.
Oh, okay, yeah. Oh, sorry.
Yes, sir.
Yeah, it
Thank
was. Okay. Yeah, yeah. Okay. So, and this traceability could be in any other condition. It could be even cough syrup. Suppose you bought a cough syrup and you drank it, and now you have some issues. You got some allergy. Now you went back to the doctor and he says, but the doctor says, no, that's not possible. And you probably test it out and that cough syrup is contaminated. Probably got some fungus. Probably got some the wrong material. Someone put chalk piece in it. Now you go back to the medical shop or you raise a issue to, I don't know, whatever company that be, you file a lawsuit and that company has to go back. Oh, I made like 100,000 of these cough syrups. How come this one is bad? They have to figure out. They have to trace it all the way back. What went wrong? Is it contaminated by us or contaminated by someone in the supply chain? Right? Someone, maybe the pharmacy guy, maybe the distributor, maybe the shop fellow. Right? So that's traceability, and it's very critical. Every manufacturing industry, it's not just only cars and all. Everything, like you make any packaged products. You could be buying milk. You could be buying that juice. Traceability is key. Okay, you should be able to track all the machines that went to produce that bottle of juice. That's traceability. Something as critical as
Basically,
in cars, it is legal. Government will shut off your company if you cannot trace and prove that I have this system in place and an accident happens. Your company will be shut off. That's it, simple. Yeah, please go ahead.
so basically it is required whenever something is getting damaged or getting wet.
Sorry, my friend, your voice was breaking. Can you repeat?
So now it's audible or not?
Your voice is
Hello.
very low. Yeah.
Yeah, your
Can
voice
you?
is low, but yeah, you're audible. Audible, yeah.
The traceability is basically required when something is getting damaged or wet.
Uh, Required for what is it? So the last part. Can you anyone here? Can you summarize? Can someone add that? What is he saying? Can you help here? Anyone?
Hello.
Yeah. For
So
audit,
now,
yeah,
Yeah, yeah.
yeah, yeah. Audit is yeah. Audit is just a, yeah. You can think it's a legal way. Yes, it is for audit. Yes.
so now
Me
am I
and
audible?
it's, yeah. Now yes, please.
Sir, I was asking that traceability is basically required whenever something is getting damaged or bad.
Yeah, good one. So some of you might have studied statistics. And why do you do sampling? I'm testing bulbs. I make, so let's say we all make bulbs. Can I fuse all bulbs and figure out how good the bulbs are, or do I take a sample and test it? Right. So we are not waiting for damage to happen. We are just making sure something happens. We should be able to trace it. So systems are more in place of a proactive measure, right? So yeah, we need to capture enough detail that if something goes wrong or someone even has a, it could be even warranty. For example, it could be in warranty. So someone comes back after 2 years and says it's not working. This thing doesn't work for some reason, right? You should be able to not only just replace them with a free part, I mean free product, but you should also go back and figure out, oh, did I actually mess up some 50,000 units of this product? And now I'm going to see a lot more returns, right? Because when a return happens, two things happen. It's less of the money that you're paying back to the customer. It is goodwill. People will start now with all this Facebook, LinkedIn, I don't know, whatever, right? People are saying, oh, do you buy that product from X company? It is crap. I paid like 5,000 rupees and it just breaks. So your goodwill is gone. The branding is impacted, right? So any small detail you get, you start figuring out to protect your image as well. Yeah, it's not just because you have a legal implication. You also, it's a goodwill implication. It's a branding implication. Okay. Yeah. Complete IO AI. Yeah, I think you'll have Bharadwaj. You'll have a mentor who will guide you some of these. But yeah, we can share some links. It's a lot of content on the internet, not a problem. So don't try to start on. Okay, think like this, right? You are going to learn on the fly, right? On the day-to-day basis as you work, make progress. You're going to figure out some piece that you need to learn. It's not like you want to take a 6 week AI class and then you start applying it, or IoT class or something. Don't do that. That's not going to work. Okay. So yeah, you'll get some links. I'll check. Rebanta, maybe our other mentor who coaches them will be able to do it, or we can share some of them. Yeah, not a problem.
Yeah. Also, I request the college mentors to help the respective students, whoever
Yeah.
is associated with each and every team, to please guide them and give them the right direction from a fundamental point of view. After that,
Yeah,
we are there to support, definitely.
yeah,
But we cannot teach you from scratch. So you have to basically understand the fundamentals and then come prepared to take up this problem statement. So at least you take the help of your college mentors, whomever the colleges nominated or allocated for your respective teams.
yeah, yeah. And just to say, yeah, I want to build a system, existing one. See, I mean, if you take the same problem statement and go to Chat GPT or something, you will get an answer. That's not a problem. I think the fundamental, let me iterate again, is uh, take some core concepts that you have learned, and you'll have a friend who's doing. I will be, even if you don't apply like lot hardcore AI or something, it's okay. But even if you take some basic stuff and it works, your OCR works, your basic image recognition works, your traceability works, that's good. So I'm not expecting you to be building an industrial grade solution, but can you build a solution and demonstrate these are the concepts I learned and this is what I have built, right? So my only input for that person who is asking this last question about build an existing system, um, you take a system and enhance it. It also means you need to understand that system. That's important, okay? And you'll all face this in the real world tomorrow as you get into the corporate world. Is today a lot of the uh, code is being generated by GPT or something, right? Now you have to understand that code to enhance it. So yeah, you can start anywhere. If you like to do that, that's fine. But you should be able to demonstrate on that basic system, what did you learn, or from that system, how did you map it to your learning, and what extension did you do it. For example, I'll give you an example that you can take it as, so you have a someone has open source library, for example, OCR, which obviously is the case, right? None of us going to write a OCR library. You say take the same OCR library and you start applying it on pictures of labels. You find it's not working. And then you realize the image that you're providing is blurred, or the resolution is not good, or when you're taking the pictures, it is shaking up. So what do? You actually apply super resolution or some techniques on that image. You make sure that image is ready enough for that same open source OCR to read it. So now when you come to your presentation, what you're going to tell me, Mr. Kalyan or whoever, right? I took this basic open source OCR library, but then I have added a pre-processing module. No matter what kind of quality of image you give me, I apply these techniques of super resolution or improving the image quality and all, and boom, my standard open source OCR library does a great job. It is able to recognize those numbers. It is able to recognize the font. It is able to recognize the text. That's a great application of your learning. Is that helping you? Okay. Yeah, whether you need to create a label for the product. Yeah, I mean, whatever, right? You can Google online for labels of products. You can simulate with software if you can write software to create labels. Not a problem. You can take a label and try to create n copies of it. Either way, you can decide that.
Okay. Hello.
Yeah,
Sir,
please go ahead. Please go ahead.
sir, should we build a model for a specific domain or for everything?
See, everything is always starts with specific, my friend. You learn a concept, you have to start applying in a specific area, then you generalize it. Okay. So
Okay.
like suppose
We
I'll go
have
very
to choose.
basic.
Okay.
Yeah, go ahead, please. Go ahead. How to choose? Hello?
I, yes, sir.
Yeah, yeah, I'll tell you an example. That's what. So all of us, I mean, yeah, I'm too old now, 50 plus, but I mean, when I was a kid, also my mom or my teachers and your teachers and your mom also taught this. What they told you? A for apple, B for ball, C for cat. So what they told you is you have to recognize the alphabets with a thing, right? So after they told you A for apple, which was red, they gave you a green apple, but you still said it's apple. So you still have to start somewhere, right? And
Yes, sir.
between A for apple, B for ball, and C for cat, there are different things, but you started recognizing it. So you start with A for apple, make sure it works. then you can say, can I apply some abstraction on that training system that it can even identify balls, it can identify cats, right? So no one has to be prescriptive about it. You start, you pick up what kind of label you want, right? That label could be a barcode, it could be a text. You can write down a text and says 1, 2, 3, 4, 5, 6, 7, 8, 4, whatever label. Like I said, you can take a medicine strip of a medicine on which, or a bottle of Dettol, or some kind of a soap which has labels, right? And then start there. Yeah, please go ahead, Disha, or someone had a question. Yeah, simulation software, I think if you Google for it, you'll find, but let me say, I had some links in my previous other session as well. These sites have standard documentation for developers or students. I can send some of those old links. Yeah, yeah. And these are there on the internet as well. But yeah, I can share some. Please. Anyone? Sorry, you
Sir,
had someone? Please.
sir, can you drop your email so that if we have any issues, we can contact you on mail?
Yeah, yeah. That I think the channel wise, Ravanta will.
Already we are connecting you with an mentor, Devdut, whose email ID I am going to share in the chat box. So Devdut will be your point of connect after this session. Okay. So for any queries, you can reach out to him, and he will be very clear about this entire problem statement. So you can reach out to him for that purpose. So, and whatever queries you have, currently you get it clarified from our mentor, Kalyana. Okay.
Yeah.
Sir,
At the same
can
time,
you tell
yeah.
us,
Good,
sir,
good.
can you tell us how should we start this
Yeah,
project?
perfect. I'll get there. Yeah, let me be prescriptive at some point, right? To some point. So as our friend Rabanta mentioned here, see, the thing is, don't wait. That's the first problem. Like I said, failure is when you don't do anything, right? Trying things and failing is not a problem. That's not failure. That's still success. Okay. So what you should do is, I'll go a little prescriptive in a minute, my friend. So what you should do is, you should have whatever questions you have. I think we'll have some kind of a feedback loop. So you keep sending all those questions to your mentor, and we'll have a loop where Ravanta can check that out. We group them and we come up with answers. Okay. So that if there are 20 or 30 or 50 students, and maybe most of them are duplicated questions, right? They have some variation of similar. So we will come up with the answer, and so that all of you can benefit. That's not a problem. Okay. So just don't hold on. Just keep sharing that your doubts and questions, and we'll get back to you. We can do it every week or whatever. I think that's not a problem. We can make sure that you get the answers, you can get the relevant inputs so that you can make progress. Okay. To the other point, right? So yeah, any questions before I get very prescriptive about this whole exercise? Yeah, my friend, yes. Yeah, that's you can sell it. You want encryption, decryption in the QR or barcode, and that's up to you, right? So I don't know if you are a computer science or info security student or someone. You have to ask, what do you want to encrypt or decrypt, right? I mean, your barcode is like 1, 2, 3, 4, 5, and you have your QR code also probably saying 1, 2, 3, 4, 5. But yes, if your QR code is giving a lot more detail, which is internal to your company, and somehow instead of going to a database or something, you are putting as part of your QR code on that label all the details that you don't have to do traceability about, right? That's why you put the batch, you put the shift, you put the name of the person, manager who did that shift, or when it was manufactured, which company, which product, which material. All that has to be encrypted. Yes, you can put it encrypted into the label and keep selling it, and someone returns it, you scan it, and you probably see everything. You don't need a database, maybe, right? Yeah, that you have to do it, because if you don't do that, like in Aadhaar card or something, you take a QR picture, it probably tells you a lot more detail in that image. Maybe you don't want that the whole world to figure that out, but that's one option. Yes, you have to have encryption there, because you're disclosing a lot more unnecessary information for the world, right? You have to only disclose what is needed. What is needed? Yeah, a batch ID, because when someone comes back, you also need it back. But what is all these back end gory details of the shift and all that? That can be in your own internal database. Using the batch ID, you look up into that maybe some of you done SQL or something, you can look up your database and you see all the other details. So the other details can be just with a key called batch ID or a lot ID or something, right? And you only put that ID in the label. So it's up to you. I mean, you can be, yeah, nothing wrong. No limits to creativity. You can put it. But if I'm your reviewer, I'll say, oh, great, you put encryption. What encryption algorithms do you know? You want to show me that you know encryption, right? So my question is, what kind of encryption is, asymmetric, symmetric? What is public key, private key? What is, RSA? What is Diffie-Hellman? So if you want to show your reviewer, encryption, decryption, you better be prepared for such questions. Okay. Thank you. So yeah, let me start prescriptive, right? So if I were you, right, what will we do, right? Tomorrow, maybe
So where
today
should we
evening.
start from?
Yeah, that's what I'm saying. That's exactly, I'm being very prescriptive here. Yeah, if you pay a little more attention for the few minutes, right? So first point, we said you need to start creating high-level flow, right? So the high-level flow could be like, I need to start with a bunch of labels because I need to have this system to be tracing. So you can start putting, taking a label from an image or something, and you'll start working on how to identify the label through OCR or something. That's one stream. Okay. Doesn't stop you to create one more Excel. You don't have a database. You don't want to get too much hi-fi about it. In an Excel, you're going to have some 50 numbers, which are 50 different labels, and you have a bunch of data about that, right? But each label, as we talked, has to go through a number of steps in the manufacturing line. So let's say to make your product X, you go through 3 different machines. So what will X happen? You have 50 rows, 50 batches, each going through 3 machines. So you'll have 50 into 3, 150 rows of data, right? So that means you have a database of 150 rows for 50 batches, each going through each of the tool on a certain day and time, right? So you can say, okay, now I have this 150 row Excel. Now someone returns me one of the label. Can I query it? Yeah, you can write a simple user form in Excel, put a number, it will look up, or you can do a VLOOKUP, however, you get the data back. So that's very simple, basic traceability, not going very complex databases and stuff. So that's one channel. Can I trace? Yes, I can trace. And if you put that label, you'll figure out which day, which batch, which shift. Maybe you can add a shift, right? You can make it more complex, right? And which site. You have 4 factories in the world. Which factory was it manufactured? All the details you'll get. So that's traceability. Now on the label side, with the other track, you took a label of this Dettol bottle or something, which has some barcode and some model ID, batch ID, and some expiry date and manufacturing date. Now start working on taking a basic OCR from the internet and take a picture of that label in your computer and apply the OCR and say, give me text out of this label. You can Google online, you can ask GPT, chat GPT, say, I want a simple OCR to read a image with label with text and some numbers, and I want a text out of it. It'll give you like 50 lines of code. Their open source libraries are there, Tesseract and there is Python libraries, PyOCR and stuff. You'll get it from ChatGPT. So by, let's say today is Thursday, right? By Sunday, you should have an Excel file with 150 rows. You have an OCR that given any image, you can take 4 of these labels from something that you had home, and it may not be the same product. Let's say, don't worry, right? You or go to your grocery store, and I hope the shop fellow won't worry. You take a picture of 4 labels, maybe a soap, maybe a Dettol bottle, maybe a shampoo bottle or something, and you run those 4 images with the OCR. And when you run that, you might get the text as you are seeing on the label physically, or you might get some blurred text. You might say, instead of saying ABC 1 2 3, it might get ACD or something like, or it will be getting confused with B and some other letters, right? Or like D, right? Typically the OCRs, if the text image is not clear, it'll confuse D with O. So if it instead of saying ADK, it might say AOK. So now your next phase, you are able to get some text out of that 4 images, but it's reading ADK as AOK. So what do? You go back and apply the pre-processing logic on that image. You apply a logic where that image is enhanced. As you can Google for ChatGPT and it'll ask you, it'll give you, but you know the concept. Like our friend was saying, I'm going to apply encryption. So you're not going to get done because someone bad like me will be in the interview and you say, I applied super resolution. I'm going to ask you why. I mean, what is the algorithm? So better be prepared with that, because what you did, you just asked ChatGPT to give an algorithm. So you better know what is super resolution, what is the underlying technique that super resolution applied, how did it process those pixels to get that clarity. So know that concept. If without knowing the concept, you're not learning anything, right? So you do that. So let's say that's like next Monday, Tuesday, maybe Wednesday. So by next Wednesday, you have 4 labels that you run through your PyCode. You should get awesome text out of it. You should have 150 labels in Excel, and you put any of the text from that OCR label, you should be able to get 1 row out of it. 1 row, or maybe in our case, 3 rows, because that batch matches 3 rows. You should get 3 rows with 3 tools, but it's only 3 tools on the same factory on that same day in the same shift, right? Because that batch should be unique. It cannot be the same batch ID across your whole factory, right? That's going to be dangerous, because you're going to put the same batch ID in, say, India, Malaysia, China, I don't know, Europe, somewhere in manufacturing. That's not going to work. So you want to make sure that your batch ID is unique across all your factories. You put a batch ID, you get exactly 3 rows of that shift, of that time, and of that machine. So you get 3 rows. Now you're saying, I got my traceability, but what went wrong? So you come up, like one of our friend was asking, quality, what is that? So you can say, oh, I'm actually saying this soap is too liquidy, right? The concentration is not right. So what you do, you're going to create one more Excel sheet on the same Excel, one more sheet which says product quality test parameters. So you're going to say, whenever I have a batch, I'm going to check 3 parameters. One, if it's a soap, let's make it up. If it's a soap, 1 parameter, the amount of lather, the foam, right? You measure it some way. Let's say you measure it some tool and you say, okay, this is like some percentage, 1, 5, 10, whatever, right? And then second is the amount of concentration. So can you measure concentration? Yeah, I mean, there will be ways to it. Let's say you come up with a concentration measure, and that number is like any number between 1 and 10, but your quality standard says it should be at least 8. If the product is not having anything less than 8 concentration or greater than 8, you are not going to sell it to your customers. So you will have a bunch of test results. So we have how many lots? Are you listening? How many lots did we have? Not
Can you
listening.
repeat the question?
How many lots did we put in our batch? How many batches did we manufacture in our Excel sheet?
3 batches. 3.
No, my friend. 3 is our
150.
steps, tools. 50.
Oh, sure. Wait.
Yeah, we manufactured 50 batches or 50 lots.
Yeah,
Each lot
50
went,
to
yeah. Each
total
lot
is
went into
150.
3 tools. Yes. Each lot
Yeah.
went into 3 tools. So when I get a bad product back, I'll get 1 batch ID, which will match 3 rows because I'm using 3 tools, right? So the traceability is done. I know that this batch got processed on 3 tools. Now, when I go to my quality sheet, which is my second worksheet on the same Excel, I say for this batch, what were my 3 product qualities? What was it we said? One is lather, one is the concentration. You can make up one. Let's say we'll take 2 only. The thickness of the product and the lather it produces, right? So now we know what are the quality parameters for this batch. And then we look up at the data and we say, oh, by the way, this product had only like 7 or 5 concentration level. What went wrong? We shipped the product. As per our quality standards, if the concentration levels were not greater than 8, we are not supposed to ship this product. So now you can go back and say, something went wrong. My engineer was sleeping, or my quality engineer, basically, not the engineer. My quality engineer was sleeping. So he was supposed to look at the test parameters and make sure unless it meets my standards, I'm not going to ship it. But this batch clipped that test and went to the customer. Is that now making sense? This should be done by next Friday. Is that a lot of work? Abhay, Ayush, you want more? Is
Understood.
that helping? Yeah, you can come up with your
Yeah,
own
it
batch,
is.
lot, numbers, and quality parameters, right? So by next Friday, you should have a database for traceability, a basic OCR algorithm that can scan some label and come up with some details, a algorithm or piece of code that enhances a label so that the OCR works great, and then another sheet of quality which tells you why this product was bad, right? What is the problem with this product as per your own set of quality metrics.
So the first
So
one
your
was database for traceability. After that,
yeah, first is you have to have a database of for data traceability is the next part. You have to have a database of whatever you manufactured, right? So you manufactured 50 lots, 50 batches through 3 different tools, right? In one factory or more than one factory. So the 50 rows or 50 batches will be spread across 3 factories, right? So you have a column called batch ID. You have a column called factory ID or factory name or location, right? It could be India, China, Singapore, Germany, right? And then you have another column which says shift number, shift 1, 2, 3, right? And then you have a timestamp, which day was it, right? That's the other column. Then you have one more column which tells you what should it tell. You have batch, you have factory, you have shift, you have time. What is that you have to have? One more. In the factory, what happens? Does everything get manufactured in one tool?
no.
Yeah. So your other column
So
there is the tool. So let's say your manufacturing process has 3 tools. So your product goes through tool 1, goes to tool 2, goes to tool 3. So every batch will have 3 rows for 1 row per tool. So the first row will be like 10 a.m. of 11 November 2024 or 12th November, whatever. And then 10 minutes later is the second tool, third row is the third tool, right? Similarly, on the quality sheet, you will have quality parameters for the overall product. You might also have quality parameters per tool. So if you want to get more detail, you can say after tool 1 does the job, what is my quality parameter? Right? Let's say the first tool is only mixing chemicals to measure to do whatever to ensure lather, and the second tool mixes water, right? So the concentration part happens on the second tool. So the quality parameter for concentration being 8 or more comes from the configuration or tuning of the tool 2. So if my concentration was less than 8, which tool should I suspect? Tool 2. We have to find out who was the manager for tool 2, who was working on tool 2, who calibrated tool 2 on that day, right? Then we can say, buddy, why did you tool not configure the tool right? That's a question for the person running the tool. Then we have to ask the quality engineer, you were supposed to take the quality of this product and it is showing 7. You were not supposed to certify for sale. Why did you not do that? Right? Is that making sense, Ayush? Now,
yes,
at
sir.
level of detail? Yeah, okay.
Yeah. Yes.
So guys, by Friday, you're almost done with the basic stuff of the project, right? By next Friday. Or am I
So
missing something?
by next Friday, we just have to have all the data in Excel sheets, a basic code maybe.
Yeah. By next Friday, you should get through whatever we just outlined, go through the recording, take
All right.
notes out of it. And once you have that, you should send a bunch of emails to your mentor and Rabanda saying, I have questions on these A, B, C specifics. And then we can go further, right? I think you have like 6 weeks or something. So by first week, you should have the basic prototype working. It's called in the corporate world or design world, it's called MVP, minimum viable product. By next week, you have a system that has traceability data, can apply some identification of a product, match it to the traceability, and figure out the quality parameters. Is that helping?
Yes, it is.
Okay, thank you. Anyone else, my friends? Yeah, I mean, no rush. Please go through the recording. Please make some notes. And yeah, definitely no one is stopping you. And yeah, let me go. You can use ChatGPT. But the only thing I'll tell you is if ChatGPT tell you something and you're going to proceed in the report, I would request your reviewers to ask you questions. Okay. It's good to use a tool, but it's bad to not know what it's doing. Okay. Otherwise, you will be like any of those film actors or showbiz, right? They show you something. Yeah, this soap is great. This bed is great. This car is great, right? They have no clue of what they are trying to, be ambassadors for. So let's not be ambassadors of something which we don't have a clue about. Understand whatever code and design the machine is telling you or GPT is giving you, and then see how you can enhance it. So that when you come back to the review presentation, you can say, I took the basic thing from GPT, but by the way, I applied these ABC learnings which I've learned, and this is how I enhance the tooling, right? I definitely we don't have to reinvent the wheel, and you have to there's a famous saying which says stand on the shoulders of giants and see farther. So leverage those tools, but you have to have your own branding on the tool. Okay? You have to bring your own thumbprint on it, right? Your signature on whatever you're building, and that's the value that you have. Okay, all good.
All good.
Yeah, thank you. If you don't have any questions, yeah, I can be there. We can be there for a few more minutes. Otherwise, we are done, I guess. Yeah. Okay, we are done.
Kalyan,
Yeah, please,
I just wanted to clarify one thing.
please.
Is the you can make it clear to them so that
Sure.
when they submit the project, they are aware that okay, this is what is needed. So any kind of demo or any kind of application has to be built, right? At least a working model or a prototype or some kind of simulation based demo.
Yeah, it is mentioned in the document. What is
Okay.
the, yeah, we can review if at all there's a question. I think the deliverables are mentioned there. If there is some confusion, yeah, we can.
Okay.
Let me share. I think, yeah, it is there. At all, we can put more. And I was thinking that the mentor can also improve it. I mean, I gave a very high level, some kind of
Got it.
general
Yeah.
thought. Yeah, it
Hmm.
is there in the document. Yes.
Okay.
Yeah.
And any specific Intel tools that you suggest
No,
to use
nothing.
them?
Nothing needed.
Okay.
Nothing needed. Yeah.
Okay.
So the deliverables on like page 3, it is there, like 6 of them, but yeah, roughly you can pick. But the core is actually like 2, 3, and if you are more like mechatronics, you probably want to use 4, and 5 is needed because that's fundamental to the whole project, and 6 is obviously a report out or something, like, and the documentation. Yeah, nothing. Yeah. So the idea is, see, we don't want you to burden with the process. The idea is to learn and demonstrate your learning. So it's less of doing a complex presentation, you spending some 10 hours trying to create a PPT where there's no subject, right? If you have enough subject, even if you write a paper or a paragraph of text which kind of gives the concepts, it'll be better than creating a nice slide deck which there's no substance in it. Okay. You can even ask GPT and say, is there substance in my presentation? It'll tell you whether it has or not. Okay. The core is demonstrating the subject and learning. Yeah, I think it's there, Rabanda. Yeah, we can check with the team.
Okay.
No
Fine.
problem. Okay, team. Thank you.
So, guys, last minute, any more queries or else we will wind it up?
Yeah, I hope you have some starting point. I think we went through kind of very prescriptive steps. So if you try the same exact steps, by next Friday at least you should have something working.
Right.
Yeah.
Okay, I think no more queries. So thank you. Thank you, Kalyana. Thanks for your
Thanks
time
everyone.
and support. Yeah. So guys, I will be sharing the recording soon, and
Thank you so much,
along
sir.
with the along with the slides and other necessary information, and also you will have a next live session maybe by sometime in the next week, or we will keep you updated based on the availability of mentor Devdyut. And also we will request Kalyana for one last live session maybe by in the middle sometime, maybe in the mid of June sometime, before the project submission date comes. Okay. So yeah, thank you all and all the best
Thanks.
for
Yeah. All
this.
the best,
Yeah.
folks. Yeah. Keep
Yeah.
learning, keep doing. Thank you.
Thank you. Thank you. Bye.
Bye.
So when will be the